Physics Lab 2 Intro. Purpose was to observe the motion of an object in 2 dimensions, projectile motion, and observe the effects of air resistance. Important equations, the force of drag equals negative the drag proportionality constant, velocity squared times the unit vector for velocity. Velocity final equals velocity initial plus F net over m delta t, and position final equals position initial plus velocity final delta t, and you can use velocity final because the force is non-constant. So idea, constant velocity on Earth is nearly impossible because of drag and friction. Our result was that the ball of paper lost velocity in the x direction, and it traveled in a parabolic shape. The paper ball was the system, the surroundings is everything else, where our force of gravity and drag comes from. Process assumptions and conditions. The process, an object was thrown, its motion was plotted. Position, initial velocity, and time was used in the model to get theoretical data, and the data was compared. Assumptions, the camera was perfectly in line with the motion, the object's point mass, and the net force is non-constant. The final velocity is used in the position update formula. Conditions, the object was thrown at velocity negative 2.44 and 2.670 meters per second. The drag proportionality constant for the paper ball is B equals 0.00222304, and the ball had an initial position of 1.1580 meters. The model was given in the procedure. The initial conditions were updated. Cahotas ran twice, once with B equals 0, once with B equals 0.00222304. The net force calculations were added, and update formulas were input. Our results, the graph shows the difference between experimental and theory. The theoretical, it moves in a parabolic shape. You cannot see it very well, but the one on the left is a model ran with no drag. One on the right was a model ran with drag. You can see the arrow for the force of drag, big and orange. Important questions. What does it mean? So none of the scenarios involve terminal velocity. The net force of the object in the y direction never equals 0. To find the terminal velocity of the object, we would need to drop it from somewhere high or throwing it higher in general. What if the ball was thrown straight up? It would have taken longer to land because the force of drag would have been acting directly in line with the object's motion to the floor. Error. The camera was not perfectly aligned. Tracker does not account for camera warp, and the camera was not perfectly level. Conclusions. Constant velocity motion is almost impossible to achieve on Earth due to air resistance and friction. Drag had a large effect on the motion of the ball. Without drag, the ball would have had a constant x velocity, which was not present.